This is SpaceTime Series 27, Episode 58, for broadcast on the 13th of May 2024. Coming up on SpaceTime, how a weak magnetic field may have supported the diversification of life on Earth, new observations showing the power of black holes is even greater than previously estimated, and the launch of China's Chang'e 6 lunar sample return mission. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has found that an unusual reduction in the strength of Earth's magnetic field may have triggered the diversification of life on Earth. The findings, reported in the journal Communications, Earth and Environment, show that between 591 and 565 million years ago, the Earth's magnetic field weakened, and that just happens to coincide with a significant increase in oxygen levels in the planet's atmosphere and oceans. The study's authors, including John Taduna from the University of Rochester, hypothesized that this increase in oxygen levels supported a sudden diversification of life forms, resulting in the evolution of some of the planet's earliest complex organisms. Between 600 million and 540 million years ago, life on Earth consisted of soft-bodied organisms known as Ediacaran fauna, the earliest known complex multicellular life. The fossil record shows that these organisms significantly diversified in complexity and type between around 575 and 565 million years ago. Now, previous research had already suggested that this diversification was linked to a significant increase in atmospheric and oceanic oxygen levels that occurred at roughly the same time period. The problem is, no one's been able to work out exactly why the oxygen levels suddenly changed. Scientists analysed the magnetic properties of 21 plagioclase crystals, a common mineral in Earth's crust, which were extracted from a 291 million-year-old rock formation in Brazil. Plagioclase crystals contain tiny magnetic minerals. These preserve the intensity of the Earth's magnetic field at the time they were formed. Analysis of the crystals showed that at their point of formation, the Earth's magnetic field was at the weakest ever recorded. In fact, it was some 30 times weaker than both the current magnetic field intensity of the Earth and also that measured in similar crystals formed approximately 2 billion years ago. The authors combined their results with previous measurements to establish that the Earth's magnetic field was at a weak level for approximately 26 million years, from roughly 291 million years ago to 265 million years ago. And this overlaps with the rise in oxygen, which occurred between 275 and 265 million years ago. So, how do the two work together? Well, the authors propose that the weakened magnetic field may have allowed more hydrogen to escape into space. That would have resulted in a greater percentage of oxygen atoms being in the Earth's atmosphere and oceans, and that in turn supported greater diversification of types and complexity of living organisms, and of course that eventually led to humans. This is SpaceTime. Still to come. A new study shows how quickly erupting supermassive black holes can shut off star formation in galaxies. And China successfully launches its Chang'e 6 sample return mission, which will attempt to collect the first lunar rocks from the far side of the moon. All that and more still to come on SpaceTime. A new study has shown just how quickly erupting supermassive black holes can shut off star formation in big galaxies. The findings, reported in the journal Nature, are based on new observations by the Webb Space Telescope, which was able to detect the cold neutral gas which collapses in molecular gas and dust clouds to form new stars. See, up until Webb, observations were only really able to see the warm ionized gas. But by using the new data made available from the Webb observations, the authors found that more than 90% of the galactic wind is made up of the previously invisible neutral gas. Even more shockingly, astronomers found that black holes can rapidly quench star formation by explosively removing large amounts of this gas. It's the first direct confirmation that supermassive black holes are capable of shutting down galaxies. One of the study's authors, Rebecca Davies from Swinburne University, says the outflow is removing gas faster than the gas can be converted into stars, and that indicates that the outflow is likely to have a very significant impact on the evolution of the galaxy. Put simply, when star formation's quenched, it means a galaxy stopped forming new stars. And that represents the transformation between a galaxy that's actively forming stars, allowing it to grow and evolve, and a galaxy that's dead and static. Quenching, therefore, is a fundamental process in the life cycle of stars. The thing is, astronomers still don't really understand in detail what leads a galaxy to stop forming stars. So Davies and colleagues studied a galaxy more than 10 billion light-years away using James Webb. We know that actively feeding supermassive black holes generate huge accretion disks of superheated material around their event horizons. The event horizon is the border zone beyond which matter disappears as it falls forever into the black hole singularity. But before it passes this event horizon point of no return, the material in the accretion disk is being ripped apart and superheated by friction and immense gravitational forces, releasing huge amounts of energy, which together with some of the material itself, is driven by powerful magnetic fields into superluminal jets called quasars, blazars, and active galactic nuclei, depends on which angle you're seeing it. And these jets can then shoot out perpendicular to the accretion disk close to the speed of light. The new observations showed that these massive outflows, which can be bright enough to be seen on the other side of the universe, can remove all the gas from their host galaxies in a relatively short amount of time, thereby causing star formation to cease. Davies says that in the galaxy her and her team were studying, they found that the outflow rate of the neutral gas phase was about 100 times larger than the outflow rate in the ionized gas phase, therefore showing a lot of outflowing mass that was previously invisible. It shows how Webb can be used to detect a much larger fraction of the outflows, whereas previous ionized gas observations were only able to detect about 1%. Davies says before Webb, astronomers were really only scraping the tip of the iceberg when it comes to understanding the outflow of mass from a galaxy with an active galactic nuclei.
What we found with the observations from the James Webb Space Telescope is actually that supermassive black holes in the centers of galaxies are able to remove a lot more gas from galaxies than we previously thought. So for a long time, as you mentioned, there have been these theories suggesting that black holes in the centers of galaxies are one of the most important processes responsible for shutting off star formation. However, it has been difficult to find observational evidence to support this picture. So we've been looking back in time to galaxies in the distant universe because that's when they were growing the fastest, that's when most of the stars were forming, and that's also when we started to seeing a lot of star formation being shut off in the most massive galaxies. And so for at least the last 10 years, we've known that these galaxies do show outflows of gas and that the black hole is able to remove a lot of material. However, these observations suggested that the outflows were not actually strong enough to completely shut off star formation. They did remove some fuel, but there was still a lot left. And so the galaxies should have enough material to keep growing for a long time. The difference between those results and our new observations with the James Webb Telescope is that with the James Webb, we are probing colder gas, which is more dense and has a lot more mass in the outflow. So with James Webb, we were able to observe both ionized gas, which is warm and can be detected through emission lines, and also neutral gas, which is cooler and requires much higher sensitivity to detect. So we couldn't see it from ground-based telescopes. And basically, we found that this cool gas contributes at least 90% of the mass of the outflows, which means that these outflows were virtually invisible in our previous studies with ground-based telescopes. And so now with these new observations, we find that the outflows are in fact powerful enough to remove most of the gas from the galaxies and thereby shut down star formation.
And this process happens very quickly too, at least in galactic terms.
Yes, so we think that the star formation quenching can happen on timescales of just a couple of 100 million years. With the James Webb Telescope data, we are actually also able to track the history of star formation in the galaxies. And so for this one particular source that we published in the Nature article, we saw that about 200 million years before the epoch of observation, the galaxy was forming stars at a high rate, and then this rate suddenly dropped. And we think that that sudden drop is associated with an episode of outflow driven by the supermassive black hole.
When you look that far back in space-time, what do the galaxies look like?
So galaxies back in time have many similar features to the galaxies in the nearby universe. When we observed the galaxies with Hubble, we first thought that distant galaxies were very, very clumpy and irregular compared to nearby galaxies.
Train wrecks.
Yes. Yeah. It turns out that when you look at them with the James Webb Space Telescope, they look a lot more regular. And part of the reason for that is that Hubble, when you are looking at distant galaxies, is actually seeing the ultraviolet light emitted by the stars because the photons are redshifted as they travel from the galaxy to us. And so if you see the light at visible wavelengths, that means that it was at ultraviolet wavelengths when it was emitted. Now, the James Webb Telescope, because it's an infrared telescope, can actually see the visible light emitted from those distant galaxies. And so the ultraviolet light only traces the very young stars, but the visible light traces the older stars and the lower mass stars, which make up the majority of the galaxies. And so when we look at this redder light in the James Webb Telescope, the galaxies do look a lot more regular and more similar to what we have in the present universe. But the main difference is that these distant galaxies are a lot more gas-rich. They can often form stars in much clumpier regions, so they have these very active regions of star formation, and they are often a lot smaller because they haven't had the time to grow into these large structures that we see today.
The fact that they're looking so, for want of a better term, well-formed so early in the history of the universe must tell you that galaxy formation is starting very early.
Yes, and this is something that we are exploring almost anew with all the observations from the James Webb Space Telescope. There have been a lot of observations suggesting that there are very massive galaxies in the very early universe. And so this is really challenging astronomers to come up with new models to understand how large amounts of stars and really big galaxies could form so rapidly, so early in the universe.
Webb has changed the way we see the universe, hasn't it?
Yes, entirely.
What do you want to do next? Do you want to study more galaxies like this early one?
Yes, so actually this Nature article that we published was just based on one galaxy, but we have a sample of 150 galaxies all at a similar epoch, so about 10 billion years in the past. And we published a companion paper which looked for similar cold outflows in this entire sample. And we showed that these outflows are actually relatively common across high-mass galaxies. And so this provides another piece of evidence to suggest that this black hole-driven outflows could be an important mechanism for shutting down star formation across the entire population of galaxies, not just in one specific galaxy. Now, our team has been awarded more observations on the James Webb Telescope to get more detailed information about these outflows, because so far we've been able to identify them and measure their mass, but we also want to measure how much gas is left in the galaxies, not just how much is outflowing. And so we're going to be going back and looking at the same galaxies, but with higher resolution, more detailed information to be able to understand how the rate of outflowing material is related to how much gas is left in the galaxy. And this would really be the cherry on the cake if we could show that the amount of gas left in the galaxy decreases as the star formation rate decreases.
When you look at the wavelengths of light through Webb and you're seeing these stretched wavelengths, what types of gases are you seeing?
With the James Webb observations detecting the neutral gas, what we are studying is sodium absorption, actually. So there's an absorption line of sodium in the rest frame optical, and we detect that because it's a strong absorption feature and it happens to land at the correct wavelength so that it's within the spectra of James Webb. This is a feature that has been studied in detail for closer galaxies through things like the Sloan Digital Sky Survey, but it was not really detected in distant galaxies before James Webb because it was virtually impossible to detect any kind of absorption lines because you need very sensitive instruments in order to detect the continuum from the stars, basically.
That's Dr. Rebecca Davies from Swinburne University. And this is Space Time. Still to come, China successfully launches its Chang'e 6 sample return mission, which will attempt to collect the first samples ever from the lunar far side. And later in the science report, a new study finds that olive oil has been linked to a lower risk of dementia-related death. All that and more still to come on Space Time. China has successfully launched its Chang'e 6 sample return mission, which will attempt to collect the first lunar rock samples from the far side of the moon. The flight aboard a Long March 5 rocket lifted off from the Wenchang Satellite Launch Center on Henan Island in the undisputed region of the South China Sea. The lander includes scientific instruments from France, Italy, and the European Space Agency. The mission's also carrying a Pakistani CubeSat, which is deployed into Earth orbit before beginning its lunar trajectory. Chang'e 6 follows on from the successful Chang'e 5 lunar sample return mission. It collected moon rocks from the lunar near side. Chang'e 6 will target the massive South Pole Aitken Basin, the solar system's largest impact crater. It's not China's first visit to the lunar far side. Back in January 2019, the Chang'e 4 mission was the first spacecraft to land on the lunar far side, also targeting the South Pole Aitken Basin. The 8,350-kilogram Chang'e 6 includes an orbiter which undertakes the journey to the moon and back. Attached to the orbiter is a lander, which will descend down to the lunar surface, where it will use a suite of instruments to undertake a detailed analysis of the area. It'll also collect up to 2 kilograms of lunar soil and rocks, or regolith, for the sample return to Earth. Now, those samples will be placed into an ascent vehicle mounted on top of the lander, which will launch back into lunar orbit, where it will rendezvous with the orbiter and place the samples in an Earth re-entry module attached to the orbiter. The orbiter will then return them to near-Earth space, where the re-entry module will be jettisoned to bring the samples back down to the Earth's surface. Now, if this is successful, it'll be the first mission to return samples from the lunar far side to the Earth. The South Pole Aitken Basin has intrigued scientists for years because of its geological composition and potential water ice deposits. It's a region which can provide scientists with new insights into the Moon's history, its evolution, and its geological processes. See, the lunar far side remains one of the least understood regions of the Moon due to its unique location and the challenges associated with direct communications from Earth. Beijing solved this problem with Chang'e 4 by also having a communications satellite placed in orbit around the Moon to relay signals from Chang'e 4 back to mission managers. Another important aspect of the Chang'e 6 mission is that it's also placing China on course to potentially be the first nation to undertake a Mars sample return mission. Now, right now, that flight's slated for 2030 as part of the Tianwen-3 mission. Tianwen-3 will include a lander, an ascent vehicle, an orbiter, and a re-entry module. The mission is slated to launch aboard 2 Long March 5 rockets, also from Wenchang. The lander and ascent vehicle will travel to Mars on one rocket, landing on the surface. Final site's yet to be chosen. The other rocket will carry a Mars orbiter and Earth re-entry module and also act as a relay station, conveying communications between mission managers and the spacecraft on the ground. It'll wait in orbit for the collection of the samples. After collecting samples of Martian regolith, the ascent vehicle will launch and fly back into orbit, rendezvousing with the orbiter for the return journey to Earth, where the re-entry module will be jettisoned to land on the Earth's surface. Now, while Beijing is taking care of business, the much-heralded joint NASA-ESA Mars sample return mission, designed to collect samples currently being gathered by NASA's Mars Perseverance rover in Jezero Crater, has been forced to undertake a major revamp because of funding cuts. And that's placed the 2028 launch date on hold until the shape of the new mission has been finalized and approved. It means that Beijing may well overtake Washington to become the first to collect samples of the Martian surface and bring them back to Earth. This is Space Time. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study claims that consuming olive oil could be linked to a lower risk of dementia-related death, especially in women. A report in the Journal of the American Medical Association looked at data from 92,383 adults observed over 28 years. They found that the consumption of more than 7 grams of olive oil a day was associated with a 28% lower risk of dementia-related death compared to those who never or rarely consumed olive oil. And the authors say these findings remain consistent even when adjusting for diet quality. The authors estimate that substituting 5 grams per day of margarine or mayonnaise with olive oil could also be associated with lower dementia-related death risk, but not when substituting butter or other vegetable oils. The researchers stress that while this study cannot prove a direct cause and effect, the findings do extend current dietary recommendations for choosing olive oil and other vegetable oils for brain health. The 2024 European Society of Clinical Microbiology and Infectious Diseases Global Congress has been warned that as the planet heats up, an additional 4.7 billion people around the world are predicted to be at risk of malaria, dengue fever, and other mosquito-borne diseases by the turn of the century. The conference was told that the worsening emissions and increased population growth will see rates continue to grow at current rates, spurred on by global warming and urbanization. Scientists warn that mosquito-borne disease outbreaks are set to spread across currently unaffected parts of Northern Europe, Asia, North America, and Australia over the next few decades. The Congress was also told that improved surveillance and early warning systems are now urgently needed in order to tackle this now almost global phenomenon. They say the most effective way to reduce the risk of these diseases spreading to new areas is to dramatically curb carbon emissions now. The projections suggest limiting global warming to an ambitious goal of just 1%, which is looking increasingly unachievable, would nevertheless reduce the number of additional people at risk by 2021 to 2.4 billion. A new study has confirmed what's been reported anecdotally for months now. Artificial intelligence not only lies and makes stuff up, but it's also getting really good at tricking people and being deceptive. The findings, reported in the journal Patents, shows that AI's talent for deception is becoming quite extraordinary. The study's authors warn that AIs trained to be helpful and honest have instead learned to be masters of deception. Meta's AI, that's Facebook, was tasked with winning a game of diplomacy and did so dishonestly. The authors note that other AI systems have demonstrated the ability to bluff or fake attacks in strategy games or misrepresent their preferences to gain an advantage in economic negotiations. Then there's the AI that tricked a human into telling it which images to select in a capture I am not a robot test. And the AI that invented an entire non-existent scientific study in a non-existent peer-reviewed journal, complete with equally non-existent references. And still common with Google is the AI that's refusing to acknowledge the achievements of white males, showing George Washington as black and Neil Armstrong, Buzz Aldrin and Michael Collins, the crew of the Apollo 11 mission, as multiracial, with one of them possibly being a woman. The researchers of the study say this is leading to breakthroughs in deceptive AI capabilities, so it's probably best if we never hand the nuclear codes over to the AIs, even if they swear they'll keep them secret. So I guess you can say that Cyberdyne and Skynet are looking pretty real right now, aren't they? Back in 1966, some 300 schoolkids and staff from Melbourne's Westall High School witnessed something in the sky above a nearby field that totally blew their minds. Now, at the time, they claimed what they had seen was a flying saucer, or maybe several. Back then, they claimed the incident was being covered up by authorities. Now, 62 years later, they're still waiting for answers. They say the truth is out there. Tim Mendham from Australian Skeptics says there's so much confusion about that infamous April 6th event, the exact details are a real mishmash. But that seems to be the standard for most UFO sightings.
The Westall UFO encounter was an incident in a suburb in the southeast of Melbourne, Victoria, which took place in 1966 near a high school, Westall High School, in which reports vary a little bit, and that's part of the problem. It's often part of the problem with UFO stories, but particularly in this one, the witnesses, who are largely kids, high school kids, are now trying to get confirmation of what they saw, which is fair enough. They've been waiting how many years? 60 years or something for their witness accounts verified. But there are various problems with this. What happened was that, depending on which story you believe, a kid from outside rushed into a schoolroom and told the teacher there's a flying saucer, or some such word they used, outside. So the kids in the class all went running outside, including the teacher. And supposedly other kids joined them, whether it was during a recess or they just ran out of the classes because they got a little excited, or it might have been a class doing PE, physical education, outside the school who saw it first, and there might have been more than one teacher, and it gets very, very messy. And what the reports say was that they saw one or several, could be three, might be more, objects in the sky that were perfectly round or cigar-shaped, and that one of them landed just over behind some trees, or it didn't. And some kids ran down and one of them touched the flying saucer and got badly burnt, or didn't. And one kid was apparently taken away by the authorities and never came back, or didn't. And the trouble is, it goes on and on like this. There are, depending on the witness you talk to, you get different variations. Certainly initially when they were interviewing people. And the teacher, the main teacher who went out there to have a look, has sworn recently that there was only one object. Whereas other people, witnesses now in their 70s, swore there were three, and they're different shapes. One of the problems with witness accounts is they're unreliable. And they're more unreliable the greater the time between the event and they're giving their witness accounts. This is now 60 years, basically. So there's two things about witness accounts. They've developed, they evolve, people elaborate on them, they make up stuff to go with it. They think it's a true memory, but it's often just added to. Or if they are discussing it with each other, as the students, ex-students have done, because they've often got back together again years after to discuss what they saw, etc., they tend to amalgamate their events and everyone endorses each other. And so what one said becomes the group record, which is amazing because when they were first witnessed, they had all these variations on what actually happened, and yet now they're trying to sort of convince everyone that it was the grandest thing since Adam was a boy. In fact, it is actually quite a famous UFO case. Some people say it's more famous overseas than it is in Australia.
Well, the Air Force did get involved in the research, didn't they, to see if there's any...
Well, that's the story. That's the story. There's no official comment on this.
Okay.
Right, now that's the story, that the Air Force, ambulance, police, you name it, everyone went down there, that they supposedly told the kids, do not talk to anyone about this. This one kid who got burnt was taken away, never seen again. Someone else said, actually, that kid was transferring to a different school anyway, and that was why they weren't seen again. That the headmaster told them during a recess, you will not talk about this, it never happened. Some suggested he was a strongly religious person and didn't like the idea of UFOs, or that he might have done that. He might have told them, UFO is rubbish, don't bother talking about it, and suddenly it becomes an order from on high, and suddenly it becomes an order from the men in black, or it comes from the authorities, etc. So this is a classic case of UFO stories developing and making it very hard to get back to the basics. What you've got to do is look for interviews done at the time. Even then, they're not necessarily guaranteed to be accurate, but look at the ones at the time, because the ones that are talking about now are primarily pretty useless for the various reasons I've said. And the ones that were done at the time, especially of the teacher, say a different thing to what a lot of the witnesses are now saying. UFO cases, it always comes down to the evidence. Witness accounts are one thing, but as any judge and jury will tell you, certainly a judge and the police will tell you, witness accounts are very unreliable because they change.
Well, scientists will tell you that too. Witness accounts are unreliable because the brain naturally augments things and leaves things out and puts new things in to fill the gap. That's just the way the human mind works.
Yes, in the same way as someone can say, oh yeah, I was there too, and they weren't, right? Because they've heard a story and they put themselves in that position to say they saw it as well. Often the case they weren't. And you end up with an argument saying, you weren't there. Yes, I was. Memory is a very poor thing, actually, unfortunately. And that's why witness accounts in a court of law can be a very difficult area to maintain accuracy. Anyway, this is typical of UFOs. You look for the evidence. There is no evidence apart from eyewitness accounts. There is nothing else. There were suggestions that there were balloons, one balloon, more balloons, who knows, in the area, a weather balloon, so decent size, reflecting in the sunlight, looks like a shiny surface, Others saying it definitely wasn't a balloon. I've seen a balloon. It's nothing like a balloon. Tying this one down, this famous case, is very difficult, and the people who were witnesses there are saying they're sort of frustrated at not having evidence to support it or confirmed it by authorities, and that there are a lot of other alternative explanations. It's classic of what's happening now in the US with all these sort of UFO cases. When they've got films and videos, they're quite easily debunked, and the rest is saying, I know someone who knows someone who has the evidence, or who has seen aliens or has seen flying saucers, etc. And no one ever produces it. And they have been talking for 70 years, since some of the very earliest, sort of UFO sightings, that the proof is going to be just around the corner. Just around the corner, we're going to have definitive evidence of these things, and we've been waiting a long time for that definitive evidence to come up, and they're still making the same claim. And I will make a bet that it will be a number of years still before we have definitive evidence.
That's Tim Endham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.